All right, hello and welcome everyone. We have a request for this particular question here. It's question 7 from exercise 4.2. And in this case, they're asking us to find the equation of a tangent and then a normal. Both tangents and normals are straight lines. So ultimately, all this question is asking us to do is find the equation of a straight line. Now, to find the equation of a straight line, there's two things you need. You need to know the gradients and you need to know the point. Now in this case, they haven't told us what the gradient is. All they've said is we've got this curve. Here it is, y equals e to the x squared. And we're trying to find the equation of the tangent. We're going to do part A obviously to begin with. At the point 1e. So we actually already do have a point. That means the only thing we need to find here is going to be our gradient, right? So remember, to find the equation of a line, you get the gradient, you get the point, and then you put it into the point gradient formula. That is y minus the y value will be equal to the gradient outside of x minus the x value, right? Where the x value and the y value are the x and y values of the point. The gradient is, of course, the other thing we need to find. So really simple, find the gradient, find the point, put it into point gradient formula. And in our case, it's extra easy because we already know what the point is. That means the only thing we need to find is the gradients. So how do you find the gradient to a curve, right? Because a curve, the slope of it keeps on changing depending on where you are. Well, fortunately, that's what calculus is all about. So to find this gradient, we're going to start off by writing the equation of the curve and we're going to differentiate it, right? So when differentiating exponentials, so what will y dash be equal to, right? Whatever there is up in the index, whatever the power is, in this case is x squared, our first job is to differentiate that. So in this case, again, I wouldn't normally be writing it down. I'll just do it in my head. We've got x squared there as the power. I'm just going to, in my head, differentiate that. You know, and just use just the normal way of differentiating. Power down the front, 1 away from the power. So it's 2x. So what would happen is you differentiate the index. That comes down the front. And then the exponential itself will remain completely unchanged. Congratulations, we've just differentiated. Why do we want to differentiate? Well, because any value we put into this derivative right here, any value of x we put in will give us the gradient at that point. So if we want to know what the gradient is of the tangent at 1e, right? Hey, what is the x value? It's 1. What we're going to do is let x equal 1, because that's the x value at the point. So when we sub 1 into this y dash, right, this will give us the gradient at that point. So we have 2 lots of 1, all times by e to the 1 squared. In other words, you have 2 times ultimately e to the 1. Our gradients, right, this is our gradient. I'm going to put m here. This right here is the gradient of our tangent. So we know what the gradient is. We know what the point is. It was 1e, that was given to us. Now, if we want to find the equation, again, we're going to sub these things into the point gradient formula. The point gradient formula. It is what we use to find the equation of lines. So it'll be y minus the y value, right? And that will be equal to the gradient outside of x minus the x value. I'm just going to expand out the brackets. Take this negative e across. So you have minus 2 lots of e plus another e. That takes you up to just a minus 1e. In other words, just e. And this here is your equation. That there is the equation of the tangent. So that's part A done. That's how we find the equation of the tangent. Part B is actually going to be just as easy. It's asking us to find the equation of the normal. So to find the equation of the normal, remember a normal is a straight line as well. So let's say hypothetically we have, our exponential is going up like this. We're at the point, 1e. This here in green was the equation of our tangent. That's what we just found in part E. That equation there right at the bottom, that's the equation of our tangent. Now, part B is asking us to find the equation of the normal. Now remember, a normal is a straight line that is perpendicular to the tangent. Perpendicular means they cross at right angles. So if the green line is a tangent, this here in blue is going to be the equation of the normal. Now, how do you find the equation? Well, there's no tricks to this. It's a straight line. So you need the gradients, you need the points, and then we're going to plug it into the point gradient formula. Same thing every time when you're trying to find the equation of a line, whether it's a normal, the tangent, or any other straight line, to be honest. Okay, so the point we already know. We have a point on this normal. It was at 1e, so we already have a point. Tick that off. All we need is the gradient. Well, this is actually going to be quite easy for us because we already have the gradient of the tangent. The gradient of the tangent, let's put the little t there, just because there's two different gradients here. The gradient of the tangent, gradient of the normal, right? The gradient of the tangent, we learnt from the previous question, we calculated it using calculus and it was 2e, right? Go back here where we found the gradient. It was found over here. We end up getting 2e. That's the gradient of the tangent. To find the gradient that is perpendicular, right, we learnt this from prelim, it'll be the opposite sign. So since that was positive, it's now going to be negative, which we can see from the graph. See how the normal sloped down? It has a negative gradient, and it's going down because the tangent was going up. But anyway, you change the sign, and you do the reciprocal of whatever it was. So in this case, the gradient that is perpendicular, or at 90 degrees, will be a negative 1 on 2e. This here is the gradient of our normal. So we have our gradient, negative 1 on 2e. We have our point, which was just 1e. So we've got our gradient, we've got our point. We know how to find the equation of a straight line. Y minus the y value is equal to the gradient outside of x minus the x value. Now again, you can just go ahead. It depends on whether you want to put this in. What does it want it in general? It doesn't even tell you. So we can just keep it. So when you're writing the equation of a straight line, I should probably explain what I'm thinking about. There's generally two different ways you write the equation of a straight line. In general form or in gradient form. And what we did was, we did the first one in gradient form where we had y is equal to. The question doesn't specify how we put the equation, so I'm just going to do the same as well. I was tempted to go into general form just because we have this fraction here, but we don't need to. So I'm just going to do the same thing that we did last time. Expand out the brackets. Two negatives make a plus. Take that negative e across. So it ends up just being a 1 on 2e plus e. And you can leave it like that if you wanted. This is actually correct. Alternatively, if you want to simplify it a little bit, you could put this over 2e as well. And, sorry, what was actually on the bottom originally? Oh, it's just a positive e, yeah. Times top and bottom by 2e. You know, and so you could get, you know, you could rewrite this as just one fraction if you wanted, 1 plus 2e squared. But again, I don't see anything wrong with just leaving your answer as we had it right here. Right there, you've got the equation of the normal. Right, so just to recap, if you're trying to find the equation of any straight line, whether it be tangent, normal, maybe a chord, or some other sort of a thing, all you need is gradient and a point. For this particular question, they gave us the point already. All we had to use was our calculus to find the gradient of the tangent, and then use the little trick right here to find the gradient of the normal when you got to part B. All right, hopefully that helps. Let me know if you have any more questions, and I'll see you guys in the next one. Okay, bye.